Hola. So making us to re-clarify what I wrote down in this problem. So yeah, I really didn't know what was going on the other day. So I was kind of happy to see that with the stuff you mentioned here, that my answers in the final thing were okay. So this thing right here, um, all that rate determining stuff, I really didn't quite get that because of the rate they were saying like CD. Because they seem to be writing a different reaction than what I would expect here, putting the C and D together. So I'm gonna ignore that for now and address that one later. So I want to first go to what I did here and then discuss some other stuff. So, all right, so this one. Must have been in a happy, good mood with this. I've been drawing figures and stuff. So, all right, a lot of arrows. So where do we start here? So first thing you want to do is get a good idea about this and what this means. So we have two steps, and what do we do with those two steps? So what I was missing yesterday was this symbol here. This means forward and backward. That enables you to write more than one equation for what you think the rate might be. So where do we start here? So let's start here. So like the slow step is the thing that most determines what's going on. So I wrote this guy delay, slow step being second will determine the rate for the whole reaction. If the slow step is first, that's something else. You deal with that a little bit differently. Um, if the slow step is second, you basically look at it and look at the reactants. So the only reactant here is C. That's scratched out. It's scratched out because it's intermediate. So if you have to write the overall reaction, it's not involved in there. So it's like one of these things that's created and then gets consumed later on. So the overall rate of reaction would be some type of constant here, K, and then C. Now sometimes there's an exponent on a C, so I don't exactly know why I didn't put one here. So if I don't know something, I wanna definitely say I don't know. So, but apparently the correct answer assumes there's no exponent. The only reason you would have an exponent with just one thing is if they're considering like I suppose two of the same molecules coming together, because the exponents actually represent uh molecule like collisions. So this is the rate of the whole reaction, but we don't want to express it like that. We want to express it in terms of other things because it's something that goes away. So there's kind of a rule that says your intermediates should not be in the final rate law. So I'll write that down here. Intermediates should not be in final rate law. Okay. So we start by writing it with actually step one, the forward and backward reactions. So again, my writing's all over the place, so I want to explain this in an order that's a little simpler to understand. Get my shapes here. I'm starting with this one, step one right here, with the goofy dog. Okay, so forward, we're going to look at step one right here. And it says fast equilibrium. Again, normally you don't look at this step, but the reason is I want to express the rate law without using C because of this idea that intermediates should not be in the final rate law. So C should not be there. So forward, we're going like this. I'm sorry, this is going to be really wordy and stuff because I'm not good at mood or something. So here that we're going forward like this. There's two things. Okay, forward like this. Okay, A goes to B to C. So the forward rate law is some kind of constant k. In this case, I'm calling k1. And then the reactant a. Because all rate laws should just really have reactants in them. Now, backward, we're looking at it this way. So in other words, we're looking at it as if it reads B plus C produces A. Now, why is it both ways? Because things can combine to form other things, and it could also break apart to form the original thing. The other way around. Something can break apart to form two things, and those two things can also come together to form the first thing. So this is B and C coming together to form A. So how do we write the rate law based on that? We say something like a K, and then we have the reactants. Now, if you just look at this here, it looks like B and C are the products, but if you reverse it the other way, they become the reactants. So these words, reactants and products, normally mean something very specific, but if you have the double arrow going both ways, they switch back and forth depending on the way the arrow is. Why did I write this guy, K -1, as little subscript? It's because it's related to this K. I don't know if they'll be like reciprocals, but it's related because it's basically saying going the other way. Now we're going to set these equal. And the reason we're going to do that is because these rates are actually the same. So actually saying that, I don't think this number has anything to do with this number. I don't know, and it's not important. But the rates will be the same. And the rates will be the same because it reaches equilibrium. So what that means is that whatever's happening, and then whatever's happening in the reverse are the same. It's kind of like, for a silly analogy, two people throwing a ball back and forth. It's an equilibrium. As long as they keep catching it, the ball's just kind of going back and forth between the same thing. So the rates for both are the same. So we're going to set equal, this is back and forth, and that's what equilibrium means. So when we do that mathematically, these cancel out. That's like two lines meeting together. And I remember yesterday when you were explaining this to yourself, because I was like pretty much like quiet, you were saying, yes, I said these equal and I get it. So that was good. So when you set them equal to each other, we get this. And we want to solve for C because it's the intermediate. We're doing that because we said intermediates should not be in the final rate law. That's like a rule. You don't want them to be there because if they're not in the original and they're not in the final, it's not like an important thing to consider, but we do need it to solve the equations. So we set these equal to each other and solve for C. That means you want to divide by this guy. So we get this equation, and which you understand because you're super good at algebra. And what do we do here? I wrote there's a pizza grease stain. I think that must have been a Friday. I think it's on Fridays. So we put this back into a lot of circled stuff here. We put this back into here. So we have K2 times everything else in this box. Now those K's, we have K2, K1, and K -1. Oops. Okay, so we got this. You can break down all K's and make it 1K because K's are all constants. Whenever you do with constants, you multiply constants, divide by constant, just becomes another constant. So that brings us back up all the way with this arrow here. So all K's combined are just a K. And so it's K times A over B. That is actually the answer. I put a question mark because I was unconfident about that. I have never actually been taught rate laws by any professor or in school that I can remember. So all this is based on just textbook reading. And I helped my cousin, the fuck is his name? Should know this. Hold Yeah, Austin. Yeah, I helped Austin with a college class on this, and I didn't see this either. But apparently, you can have a fraction, which is what the other one's saying. So I said it's either that or rate equals this, but I'm gonna say no to that because of what you found online. So this is the correct answer. We could write that another way. So I'm talking too much. But let's look at the other solution and see how that compares to this. I think it's almost the same. Except no, it's the same thing. Oh, okay. No, I got it right. All right, so no, that's the oxygen. Me sorry. Gonna mess up this guy. Yeah, let's look at this. Okay, so this is kind of the same thing, but just a little short work. So I'll just fill in the reasonings behind what they did. So you're going to hear some things repeated here. The first step, fast equilibrium. That's not the rate determining step, but it is somewhat important because it's going back and forth. Equilibrium steps help you to make the equation. And equilibrium steps help you to make the equation. This is actually the rate determining step, so that's where you start. So you start by saying the rate equals some kind of constant. It says K2, this is the second step. And then you put the concentration of the reactant, which is C. So there's only one reactant. That can't be your final answer because you want your final answer to not contain any intermediates. So what is the intermediate? You're right, it's C. I want to do a little Dora there. So what did they do? They set this equal to this. I don't think they put any reasoning behind that. It would be. My opinion, I think this is what your teacher wrote. Um, seems to be missing some information. So I would just fill in this that if you look at step one, if you look at forward, this F stands for forward. You would have rate equals some kind of K. I'm going to call it K1 because it is step one, times the reactant, which is A. But if you look at it backwards, B, we'll write backwards so you don't confuse it with the other B that's there. Backwards would be the rate equals K. It's going backwards, so I'm going to give it a -1. And then I'm going to put B and C. So even though B and C look like they're products, they're going to be reactants if you look at it backwards. These are actually the same rate. It should be in the end, so you set them equal to each other. I see what your teacher did here. She wrote the same thing. She wrote these equal to each other, so she put out the R. And then she divided by this negative K1B. All right, so like a little bit less steps than I would show, I guess. Either way is fine. So you divide by this K1B. It cancels. Okay, so we see this guy go away here, and it says C equals this fraction. Okay, agreed. You can see that over here. And then the last thing you want to do is combine this all together. So you come up with the original rate equation based on the slow step. So the final thing is always based on the slow step somehow, but you don't want intermediates in it. So you replace the C with this. So substitution, you plop it in there. And then you reduce all these Ks down to 1K. in my mind, this whole process is kind of complicated. So you might want to look at her work and my work a few different times to get a handle on it, just in case you get a question that's a little bit different. Um, so for her final answer, she put this, which matches my first thought, but I didn't think it was right, but it is, I guess. And then it says or this, so you can express everything instead of a fraction, put the -1. Yeah, because remember this b is on the bottom, so that's a negative exponent. So it's up to the top. So final answer being right equals some k. Combine all k's together. A is on top. B is on bottom, so it gets a -1. What's the overall reaction? How do they do that? So overall reaction should get rid of any intermediates. Pick a different color. So you get rid of the C's. Okay. Amy, okay. Again, if I don't understand something, I'm gonna tell you I don't get it. I don't get why the B, D, and E are together, other than the fact that like they're on the right side. So I guess when you scratch stuff out, just leave the B there. This is what I think happens. I think the B's produced, but it's not used in anything. So for the first step, A breaks apart into B and C. So B's just there, it's kind of floating around, but it's like not in the game anymore. And then C breaks apart into D and E, so those are all products. Trying to think of a silly analogy. Maybe like this: A is a cookie. A breaks apart into B and C, but they also come together to make the cookie again. Um, and then C though is a small chunk of the cookie, and that breaks it apart into D and E. So you essentially don't have any pieces that look like C anymore, but you do have pieces that look like B and D and E. They're still there. So that's where that's coming from, and it goes in one direction. And I'm talking too much, so I'm going to end this video. There we go. Close, close. And that's it.